Hello, and welcome to Associated University, a group that is designed to provide supply chain management professionals with access to information on practical solutions concerning the industry's current hot topics. Today, we will be discussing strategic slotting that can impact your bottom line. During this session, you will learn the practical approach to implementing a slotting strategy from the real-world perspective of the industry expert. For today's webinar, we will have two presenters. First is Brandon Hodge. Brandon is the Vice President of Consulting and System Integration at Associated with over 20 years of industry experience. Brandon's focus has been on warehousing applications and design, advanced systems integration, and warehouse and labor optimization. Secondly, we have Rich Wold, who is a Senior Logistic Engineer at Barcode Integrators with over 35 years of industry experience. Rich has worked with many Fortune 100 companies covering virtually all markets with a focus on warehouse optimization, process improvement, and slotting. And now I will pass it over to Brandon to get us started.
Thank you, Debbie. Much appreciated. To get started, we'll take a quick look at the agenda, and then I will pass the presentation over to Rich. Rich is truly an expert when it comes to slotting and data analytics. We will start with a review of slotting basics. This will cover the when, the what, and the why of slotting. Next, we will look at what is required to develop a slotting strategy, including a brief slotting example that highlights the why aspect of slotting. We'll also look at slotting as a process, how to get started, and operational considerations. Lastly, we will review a greenfield example where data and flow analytics were used as a basis for design and implementation. And with that, I'll go ahead and pass this over to Rich.
So slotting 101. Every warehouse manager knows that slotting is important, but it is often the last job on anyone's priority list. You know you should do it, but nobody wants to commit the valuable resources. The inbound and outbound activity often overshadows the need for slotting. Slotting becomes a to-do when I have time instead of an important need to do. The cost of not implementing a slotting strategy can have enormous effect on operations of a warehouse. It is often not realized how important until the building is out of space or congestion has become such an issue that order cycle times cannot be met. There is a fine balance between warehouse cube utilization and warehouse productivity. You want to place an item in the most efficient location, but you also want to place the item in regards to inbound and outbound processes. So a slotting strategy is the balancing of those two goals. The ultimate goal is to develop a slotting strategy that optimizes warehouse utilization and warehouse efficiency that is also integrated into the normal day-to-day activity of inbound and outbound processes. It then becomes sustainable. A good slotting strategy is one that's developed to where the inbound and outbound processes are working in unison. You don't want the inbound teams to have one approach and the outbound teams to have another, and then the slotting strategy to be even something different. Your slotting strategy will be dependent upon several factors. How are orders picked? Are they discrete picks by order, or do you batch orders and pick in waves? How is product received? Do you have direct put away? How are picks assigned to the floor? It is important that you understand the WMS when developing a strategy. You want to ensure that the WMS is configured to where it is supporting your slotting strategy as opposed to working against it. Otherwise, the WMS may undo your strategy before you even fully implement it. So how do you know if you need to develop a new slotting strategy? Typically, it's when you run out of space or congestion is starting to affect the inbound and outbound processes. The inbound has trouble receiving product the dock is beginning to be used for storage, or your order volume is increased and you are having to use overtime. As everyone knows, once a warehouse starts to reach capacity and congestion begins, it has an impact on all aspects of the warehouse operations. Receiving becomes difficult because they can't figure out where to put everything. Outbound picking gets congested. The dock gets congested with staged product. You are seeing hours starting to increase and order cycle time is increasing. You may not be able to handle the current or your future order volumes. You may not have room for new product lines coming in. These are all signs for the need of a new slotting strategy. Order fulfillment is the highest priority for productivity improvements. As mentioned, once congestion starts to occur, it impacts everything. Travel distance and order cycle times, forward pick replenishments are all impacted when you have poor slotting practices. Order processing is the number one operating cost within a warehouse, and travel time is a major factor in order cycle times. Travel time can account up to 38% of the time spent picking. Not only must warehouses become more efficient, but they also must be able to handle increased order volumes and accuracy. Order profiles are changing in all markets. Supply chain networks and warehousing practices must be able to adapt to these never-ending changes. Warehouses do not make money by the product sitting in the warehouse. They make money by moving the product out of the warehouse. So what is the cost of poor warehouse slotting? The number one is inefficiency. Efficiency begins to degrade and operating costs increase. It's not unusual for hours to have increased by more than 20% due to poor product slotting and warehouse utilization. I have been in warehouses where there was so much congestion and poor use of the warehouse that the aisles and dock were virtually blocked, and people had to climb over product to get to the items. It's not that these warehouses were that way all the time, but rather over time, things began to unravel until they got to a tipping point. Not only is there a cost to inefficient use of resources, but it also of the utilization of the warehouse itself, to where they are either using the dock as storage areas or may even be using trailers and offsite storage. The key in implementing a slotting strategy is that it is not a once in a 5-year activity. At that point, the thought of slotting becomes overwhelming. But rather, slotting is a process that is integrated into the normal daily warehouse operations of receiving and picking, so that the inbound and outbound processing are working together. So now that you realize you need to create a slotting strategy, how do you do it? In general terms, you want to maximize the warehouse utilization per square foot. And by utilization, we are referring to both cube usage as well as activity and throughput. If you look at a retail outlet, grocery stores, for example, the shelf space is a premium that vendors pay for. Prime shelf space is at a premium. Warehouses are no different. The warehouse square footage in the prime pick areas are at a premium, and they should be targeted to handle as many orders as possible. When you start to work on developing a slotting strategy, you will need to know how orders are released and processed. How are they picked? You need to know product attributes, such as dimensions, unit weight. You may also want to know product affinity and possibly order affinity. What items are sold together, and what is the normal order size? So developing a strategy. So now you know that you need to implement a new slotting strategy. So what now? How do I start? First, you want to start accumulating some basic data. The profiling of orders is very important. You will want order history information if available. You will use this to start to create an order profile. Are items usually picked in cases? What items are on small orders or on very large LTL orders? What percentage of the orders go out UPS or parcel? Warehouse location attributes. What type of storage media are they using now? Do you replenish forward pick locations? And if so, how many replenishments are you doing each day? And of course, you're going to need item attributes, dimensions, weight, vendor, and other item characteristics. Your goal is to optimize the activity per square foot in your warehouse. So major considerations include item attributes. What is the average number of orders per day for an item? What is the average order quantity? Is there seasonal volume? The average units sold per day? Average number of orders per day? Do you like items need to be grouped together, or do they need to be separated? What storage media do you currently have? And also, what storage media you might not be using that you may want to consider. This can be very important when you're trying to optimize building utilization. Are there product categories you need to be concerned about? The development of a strategy is really a two-step process. First, what storage media should it be in? Secondly, where should it be located? Many people think that the units sold per day, or cube velocity, is the primary and most important factor when developing a slotting strategy. But it is not. It is a factor, but not necessarily the most important. The units sold per day value is not used to determine where it should be located, but rather what storage media should it be in. For example, you have two items. Each are sold 100 units per day. But one item is picked on 100 different orders. The other item is only picked on 5 orders per day. While those two items may have the same cube velocity, they have a very big difference in how they would be treated in your warehouse. The units sold per day is to determine how much space an item requires and preferred storage media, but it is not the prime factor when determining where in the warehouse an item is located. Of all the factors to be considered, activity is probably one of the most important. Activity, or the number of orders per day, is used to determine where in the warehouse it should be located. So units sold per day and activity work together when determining the optimal placement, but they have distinct functions. Activity is used to determine the product's relationship to the other items, which has higher number of orders, and which items are sold together. Which item is going to be visited more than another. You will ultimately try to determine an item's fair share and position within the warehouse. So now you've developed a slotting strategy and ready to start implementing it. When implementing a new slotting strategy in a warehouse, you will want to start moving product as soon as possible. You want to move those items that give you the biggest bang for the buck. Which move will give you the greatest benefit, given that it takes time and resources to move that item? You may not be moving your top highest moving items. You are looking to maximize activity per warehouse square footage, and touching those items that give you the biggest return should be your goal. You want people on the warehouse floor to start seeing improvements as soon as possible. On a recent project, they consolidated items into selected prime bays. We weren't moving the highest moving items, but rather items that maximized the activity per square foot for that bay. Pickers noticed the improvement within the first days, and beg for the moves to continue faster. For example, instead of having 3 items take up 12 feet of space on the shelf that may have been picked 10 times each, we put 24 items, which were picked 7 times each per day. So instead of that shelf being visited a total of 30 times, which was the 3 items times the 10 orders per day, it was now being visited 168 times per day. So we increased that shelf utilization by 5 times. Also, when implementing a slotting strategy, you want to review the order releasing function and how it can be optimized to complement your slotting strategy. It is important that to get the greatest return on the implementation of a slotting strategy, that the releasing of orders utilize what I refer to as smart releasing. And by that I mean it takes all factors into consideration: where the products are located, the traffic, and dock utilization. So here's an example of optimizing warehouse square footage. Most people think that activity is the key factor, or cube velocity. So here we have an example of 6 items, all only being stocked on pallets. Item A, you will notice it has the most number of orders per day and units sold per day. The pallets represent how many pallets are required for a 1 day's worth of activity. Now, for our simple warehouse, we only have 9 bays that can hold 2 pallets each, all in 1 aisle. Now, if we put those pallets in activity sequence, you will see that item A gets the first positions, followed by the slower moving items. So all 6 items are placed in the aisle. So that is how some warehouses would typically place the items. The number of the pallet indicates how many times that pallet will be visited for orders. So now let's look at optimizing warehouse square footage. Again, here we are trying to position the items in such a manner to where you optimize the warehouse square footage and ultimately reduce travel. So how do you calculate warehouse square footage or an item's fair share in position? Now, this is the basic process for calculating warehouse square footage. I'm not going to go into each step, but generally you calculate the warehouse square footage allotment for an item taken given the storage media it is in, calculating what percentage of the fixture cube that item is taking, and then using that percentage as the percentage of the fixture square footage. Now, in reality, doing this manually is not practical, and this is where some systematic approach or application becomes invaluable. Not only can the application process the above instantaneously, but it can review the warehouse on an ongoing basis. Again, ideally, you want the adherence to a slotting strategy to be part of normal daily activity. So now let's take the same 6 items, but we're now going to position them based upon the item's warehouse square footage utilization. If we calculate the warehouse square footage ranking, you will see that item C, not item A, is now the most desirable item to be in the first prime position. So now we will place the items based upon this newly calculated value. You will see that item A is now not in the front, but rather it is now in the back of the aisle. This may seem to go against initial thoughts, but let's compare the 2 results. So the top block indicates the positioning of items based upon activity. The second block shows the items based upon warehouse square footage utilization. The numbers in the pallet is how many times the pallet was visited, and the number below it is the total distance that resulted in. If you look at the totals, you will see that the top block shows that you'd have traveled just over 41,000 feet to pick the orders for those items. The same orders now picked in the second block, the picker would have only traveled just over 36,000 feet. That's a 13% reduction in man hours and travel time. So by utilizing warehouse square footage and placement, we saved 13% of resources in this simple example. It may not seem intuitive first, but focusing on warehouse square footage utilization can have a big impact on warehouse utilization.
Thank you, Rich. Really appreciate the information. So where do we start? What's our approach? The process begins with data collection. You will need both qualitative and quantitative data. You will need to take a deep dive into your application to understand the current state as a basis for improvement. It's important to note that if your intent is to utilize external professional services, you will still need to address data collection and process documentation. There's no substitute for this process. Your team and internal resources, your data stewards, your supervisors, your pickers, etc., must be accessible throughout the process. Step one, you're going to need to do a walkthrough. A walkthrough with open eyes, like you're seeing the warehouse for the first time. Look for error in your pallet racking, in your bin locations, in your shelving. How are you using the available depth of these medias? Do you have product all the way to the back of those locations? Do the dust test. How long has that product been sitting there? If it's got a half inch, if it's got a couple mil of dust, it's probably time to look at whether or not that product should be disposed of. And look for opportunities to better utilize the space. Strive to understand your application, including the potential impacts that a change may have to the upstream and downstream activities. You should engage supervisors and pickers to understand warehousing and workflow challenges. They are closest to the process and are best positioned to provide actionable information. Often a simple question like, what's hot? What's not will quickly lead to opportunities. This may require you to rethink the process, the location, or the storage media. Challenge your team to identify wasted space. Some aisles may appear to be full, but the amount of product stored may be less than optimal. Make notes and ask your team about the items and areas in question. When you're short on pallet space, find items to move out of pallet storage into hand stack, bin racking, or bin cartons. Determine what is an acceptable time supply for a forward pick location. Do you have mins or maxes assigned to those specific products? Do you have product in the right place based on that measurement? And challenge your team to identify wasted space. Wasted space can be a sign that your product is not ideally suited for the media type. Identify the picking areas. Are picking areas that are high activity items, or picking items that are high activity in less than prime locations? What items are in the first few prime pick bays? Are these items the high velocity? Are they still high velocity? Maybe they were when they went in, but something has changed. Do the dust test. Check that the first few prime bays don't have any slow-moving items that have collected dust. This goes back to our example. Are high-velocity products in the prime locations? If there are dead items in your forward pick area, it's likely time to reslot. Step two, identify the top issues. What are the drivers? Is it lack of space or lack of space in a specific area? Do you have challenges with replenishments? Congestion? Is the dock backed up? Again, downstream and upstream activities can significantly be impacted by your picking processes. Do you have seasonal product or special buys? Is there an influx from a buyer because you had a deal that was too good to pass up and you have to figure out where to put this product? Is the picking process the bottleneck? Are there issues with cycle times? Whatever the challenges are, be sure to document the issues at the beginning of the process. Step 3 is defining the dead items. While you may think you need to focus on high-moving items first, the dead items may be taking up valuable storage space in your facility. Identify and consider consolidation or elimination of dead items. Again, this is where you should look to utilize your team. They know where the dead product is, they walk by it or drive by it every day. Challenge your team to provide suggestions for process improvement. Ask them to look for empty space or dead items as part of a potential initiative. Step 4, you want to look for underutilized space. Make note of underutilized space. Can you use end caps for picks? Are there areas where you should consider split beaming and case picking aisles? This can improve available pick locations and golden zone opportunities for smaller items. Look to maximize both horizontal and vertical space in the warehouse. Be open and consider new ideas for storage media for problem or specific product types, and be open to change. Step 5, this is the heavy lifting, the commitment, the first actions. Consider what will have the greatest impact in your warehouse and with your warehousing staff. Be sure to move dead items out of your prime location, and then start by optimizing your smallest storage media type first. Move items into your smallest media to open up locations. Expect to see improvement in pick rates from this change. And as highlighted in our slotting example, focus on SKU activity per warehousing square foot. Okay, so now it's time to develop your slotting strategy. While project development is not defined as a step, project development and planning ultimately dictate the success of a slotting initiative. Define organizational resources. Who will own the project? Who will support the initiative internally? Set a project timeline and define KPIs and objectives. Know that a data-driven approach will help to validate potential changes. Work towards understanding the data available to you. Is it actionable? Do you have the weights, the dimensions, the units stocked, sold per day, the stocking profiles, etc.? You need to execute your strategy. Do you have the optimal storage media available to handle today's and also tomorrow's needs? Consider how a change in slotting strategy will impact your upstream and downstream activities. Remember that slotting should be a continuous process. Remember to assess and validate, then reslot based on your organizational needs with consideration for best practice. Okay, once you've built a model, you need to validate. And I'll say it again, you need to validate and then revalidate. Does the model look correct? Ask yourself, is this your business today and tomorrow, or does it reflect seasonality, specials, other things that may be happening over the course of the year? Do you need to plan for these items in the future? The data validation process is based on historical information, but should be forward-thinking. Sustainability. How are organizations successful? Successful organizations view slotting as an everyday activity. This cannot be done manually. In most cases, the implementation of a slotting software solution which interfaces with a WMS is the conduit by which reslotting is automatically issued during replenishment cycles. This allows these organizations to continually optimize picking locations. This moves slotting to a continuous process versus a point-in-time initiative. Consider a software-based solution to address the variability within the distribution center and to sustain slotting disciplines. Manual processes can become cumbersome over time. Incorporate reslotting into standard practices. Aim for a review time frame that suits the amount of change reflected in your business. Actively monitor your order profiles based on known KPIs, and be prepared to address changes due to market conditions, seasonality, and product updates. Keep in mind that yesterday's solution may not be ideal for tomorrow's need, and be open-minded and agile. Common mistakes. These include never starting. It's too big of an issue. We can't do it. It doesn't get off the ground. Or not institutionalizing the process or developing the standard practices to do so. Common mistake is to only focus on the highest volume moving items, ignoring the stuff that should be out there for disposition. Mistakes include moving items around within the same storage media, or not considering different storage media. Again, or not having an open mind. Often we are told that organizations started the process but abandoned it over time. Typically, feedback is that teams are often too busy, have other responsibilities, or that they found the process to be too burdensome. Know that defining and implementing a slotting strategy requires a commitment of resources and time to be successful. This underscores the importance of defining stakeholders early in the process. Okay, changing gears a little bit. The last portion of our presentation is an overview of a project where data and flow analysis were used to define an organization's warehouse design. Let's start with a little background. As the customer's business increased, so was their need for, they had a need for additional space. They were looking for a larger facility. As a result, they engaged Associated to help design a material handling concept to implement at a future location. At a high level, the solution had to account for increased efficiencies, reduce part storage footprint, increase accuracy, and reduce labor while providing room for growth. The engagement started as a sizing study using the customer's data to define future space requirements for business growth. The customer also knew that they needed to address inefficiencies. So all processes and storage medias were under review and assessed. Highlighted in the slide is the old and new facility plan views. As you can see, there has been a dynamic change in the way the customer handles product storage and movement. Here's a brief case review. We assessed the project in two phases. We set out to recognize product objectives. This is key for you as you assess your facility in your areas of responsibility. It's important to note interdependencies across functional areas. Additionally, it's important to assess material flow as part of a full scope of work. Adjustments of workflow or product placement in one functional area may not lead to process optimization as a whole. The first step in the process is to clearly define objectives and deliverables. Flow analysis is a big part of the assessment. However, the primary evaluation was data-based in this case. Understanding the movement of product in and out of your facility will provide the basis for process improvement. Phase one objectives and deliverables in this case were to create a conceptual design for the customer. This was based on flow analysis and data analysis. Provided a description of operation and an output of estimated square foot for future needs. And in this case, we provided a rough order of magnitude estimate on what these expenditures would be. Phase two for this customer was a creation of RFQ, a billable list of parts and equipment, and a detailed budget on what the expected cost should be, a review, AutoCAD drawing of the concept, and then we provided actually slotting output for the new facility as for product placement as part of the total scope of project. So here's a brief overview, a little bit about the customer and their challenges. The customer distributes full cases and product at the unit level. Many parts are components of larger assemblies. Also, due to purchasing requirements and transit times from overseas, most items were procured at the pallet level, but distribution was at the case in each level. Issues included a wide range in product velocities. On-hand requirements forced them to hold slow movers. Excessive labor was required to pick products from bin shelving and via pallet racking, and additional consolidation was required at packout. Letdowns were required to pick fast-moving product from non-floor level positions and racking. So a forklift had to come over and let down an upper level to pick a case. Items were held in multiple locations. They had limited cube utilization, and vertical space was not utilized because much of their floor space was taken up by low-level shelving. And then they had a bottleneck at the dock inbound and outbound, which is represented by the blue arrow on the slide. Here's a more defined overview of the process, including considerations we took into account when assessing the facility's need. We assessed the current state. We defined critical impact factors and desired outcomes. What is the customer's goal? What are your goals? We considered organizational needs specific to ROI, required flexibility and scalability of the solution, requirements for redeployment of the solution as it's a fixed infrastructure. Can it be moved in the future? We took into consideration employee adaptation rates and processes. How do they deal with a change in picking or a change in process? And then the solution balance. There's always a compromise with whatever solution is implemented. We developed solution media candidates based on a number of items, primarily 1 through 3, and we assessed what type of storage media and material transport was best suited for the application. And we took into account the slotting and sizing, the data analysis, where we were provided with the master order profile, weights, DIMS, and 12 months of order activity. And then we developed a future state based on outputs and considerations for growth models and customer input. In many cases, slotting and sizing is more of an art than a science. Analysis setup requires a deep understanding of the factors that impact the outputs. Before modeling takes place, a data overview helps to create a baseline for initial media considerations. We may process a site 4 or 5 times prior to an initial visit with a customer. This slide highlights storage media modeling that takes place prior to processing site data for sizing and slotting. Understanding cube ranges helps to generate baseline media for overview. So meaning small cube, 2x2, 2x4, 4x6 is going to go into a certain bin location versus a 12-inch by 18-inch case. So those are the baseline media considerations. In this example, different storage medias, or actually 6 different storage medias were considered. Additionally, golden zones have been created to optimize picking in the shelving locations. And the green level on the slide indicates the location for the fastest movers in that storage media. Once modeling is complete, the output files will provide a basis for product positioning in the warehouse. The upper table, the velocity report, provides an understanding of where our fastest movers are. In this case, Tier 1 are our fastest movers, with 47% of these moves being processed in the bulk area. The next highest area is case flow at 30%. This data provides a sanity check. On the lower table, the activity output report, this shows the total activity and the item movement by storage media type. In this case, you can see that the highest activity in the pallet locations accounts for a very small number of SKUs. Bin shelving is clearly the most labor-intensive area for this application and likely offered the greatest opportunity for improvement. If you look at the activity output report, you will see that in the upper circled area that the bin shelves have the highest number of items picked. This did represent our greatest opportunity. This slide provides a visual representation of the virtual warehouse as an output. You can see that we have the 6 storage medias represented on the left with their various sizes, and the color coding relates to velocity. Green is high velocity and red represents the slowest movers. Using this information, we can slot products based on activity. The idea is to limit travel distance and congestion in the pick process. This will help to maximize pick times. Please note that the representation does not show actual warehouse positioning of the product. This is not a warehouse layout, but it shows the position of the product as part of the design process. As a side note, the slotting study made a clear case for the use of vertical lift modules in the operation. This was based on the amount of small cube items with moderate to slow movement represented on the far left of the slide. While this was a great solution that would have significantly maximized warehouse space requirements, the customer had a preference for a non-automated small parts solution. As such, the solution was modified to address the customer's preference. The final output and recommendation based in the customer's preference is shown here. The system moved medium movers to a pick module. Automation was added to limit foot travel, and slow movers were placed adjacent to a new area for small parcel packout. A divert was created to marry case picks and each picks with large items from the pallet locations. This separate packout area eliminated travel and is ideally located next to outbound docks to minimize travel for the high volume items coming from the full pallet locations. Best practices were employed to define product movement, consolidation, and replenishment, but the basis for the design and flow was based on the customer's order histories, stocking profiles, and growth requirements. I hope this provides some insight into the thought, processes, and methods used to utilize and assess product movement. This does conclude this portion of the presentation, and we hope that the information provided was insightful and helps you to build out slotting initiatives within each of your own operations.
Thank you, Brandon and Rich, for presenting this material. I would also like to thank everyone who attended today. We hope that you found this information to be relevant and valuable to your organization. If you have any questions, please feel free to email us at info@associated-solutions.com. We would also like to make a special mention of Loyola Supply and Value Chain Center, who has become a great partner for Associated University. The center is a great place to exchange ideas and advance your knowledge in responsible supply chain management. Please visit their website for more information. Thank you and have a great day.